Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Forms a 2,4-DNP derivative, indicates a carbonyl group, aldehyde or ketone. Reduces Tollens reagent, indicates an aldehyde, not a ketone. Undergoes Cannizzaro reaction, indicates an aldehyde with no alpha hydrogen, so the ChO group must be attached directly to the benzene ring, i.e., an aryl aldehyde, which has no alpha H. Moving on to the next step. C9H10O with an aldehyde group, ChO. The benzaldehyde core is C7H6O, C6H5 ChO. We need C9H10O, so we need 2 extra carbons and 4 extra hydrogens beyond benzaldehyde. C7H6O plus C2H4 is equal to C9H10O. An ethyl group, C2H5, adds C2H5, but we also lose one H from the ring. Net addition is C2H4. So the compound is ethylbenzaldehyde. Moving on to the next step. Determine the substitution pattern using oxidation product. Vigorous oxidation gives 1,2-benzenedicarboxylic acid, phthalic acid, which means both substituents, ChO and ethyl, are on adjacent, ortho, positions on the benzene ring. The ChO oxidizes to Co and the ethyl group oxidizes to Co, giving a 1,2-dicarboxylic acid, phthalic acid, only if both substituents are ortho to each other. And for the final step, option B shows to ethylbenzaldehyde, ethyl group and ChO group both at ortho positions on the benzene ring. This gives 1,2-benzenedicarboxylic acid upon vigorous oxidation. It is an aryl aldehyde, no alpha H, satisfying Cannizzaro, reduces Tollens reagent and forms 2,4-DNP derivative. Option A para-substituted would give 1,4-benzenedicarboxylic acid, terephthalic acid, not 1,2. Option C contains a ketone group, COCH3. In addition to ChO, the ketone would not reduce Tollens reagent, only the aldehyde would, and the molecular formula may differ. Also the Cannizzaro condition is satisfied but the oxidation product pattern differs. Option D meta-substituted would give 1,3-benzenedicarboxylic acid, isophthalic acid, not 1,2. Therefore, the correct answer is B. Therefore, the correct answer is option B.